Okay, we're going to start with this one. This is lesson 14. So I'm going to begin by counting and seeing how many carbons we have. 1, 2, 3, 4, 5, 6, 7 in the longest chain. So that's heptane. I see 2 methyls, so I have one at the 3 position and the 4 position. So 3, 4 dimethyl. And now I'm going to look for the chiral centers. So I see here there's hydrogen coupled with this one, hydrogen coupled with this one, hydrogen coupled here. These are like, I guess, tripled. So this is my chiral center, one of them, and this is the other one. This is the one at 3 position, and this is the one at the 4 position. So for these, you want to take it a little slow. I'm going to analyze this one first, and then go to this one. So I see we have a small branch here, and we have 2 carbons attached to 1 carbon. So this is most likely going to be the highest priority. So 1 carbon out, it's all carbon. So we have to go 1 more out. Hydrogen. So this is going to be the smallest priority, of course, with the actual smallest one being in the back. And then we go 1 carbon out, so 1 carbon, 2 hydrogens. 2 carbons, 1 hydrogen. So this is the highest priority, this is second, and this is third. So it's going around this way. That's a counterclockwise position. So that's going to be S. So we're going to put parentheses 3S, comma, and now we're going to analyze this one. So since the hydrogen is sticking out, we're going to go ahead and analyze it like that. Whatever we find in this position, if it's RS, we're going to switch it around. So if it was like this, we wouldn't have to switch it. That would be the correct confirmation. But since it's like this, we find it first, and then we do the reverse. So let's see that right now. So we've got that branch right here. We've got 2 carbons attached to a carbon. So carbon, 2 hydrogens. 2 carbons, 1 hydrogen. 2 carbons and 1 hydrogen is greater than 1 carbon and 2 hydrogens. So this would be the greatest, this would be second, and this would be third. That's going around as confirmation, but like we said, that since the hydrogen is poking out, we're going to have to put R. So that would be 4R. And I'm going to demonstrate it again when I turn it around when this hydrogen is in the back, so we can make sure that's correct. This is the hydrogen we're focusing on, but I'm going to fit to the screen. Here's our hydrogen. Here's our methyl. So we said this was the highest priority. This was second, third. Our confirmation going clockwise, so that is correct for R. Okay, make sure everything's right. I believe it is. Okay, so I'm gonna name it first. The longest branch, 1, 2, 3, 4, 5, 6. Hexane. I look for the methyls. I have one at the 2 position, so we're gonna start with that one. 2, 3, 4. 2, 3, 4. Trimethyl. Now we're going to look for our chiral centers. I see 2 hydrogens coupled up right here, 2 methyls coupled up here. Of course, this has the 3 hydrogens. So these 2 are my chiral centers. So I'm going to go ahead and analyze the 3rd position first. So again, this hydrogen is poking out, so whatever we get, we have to put the opposite. So 2 carbons attached to 1 carbon, 2 carbons attached to 1 carbon. So this one we're going to have to check. More than likely it's going to be this one because it's got that extra attachment right here. So of course we don't count this one. We're already 1 carbon out, so 2 carbons, 1 hydrogen. 2 carbons, 1 hydrogen. We have to go 1 extra 1, 1 carbon, 2 hydrogens. 1, 2, 3, 4, 5, 6 hydrogens. So 1 carbon and 2 hydrogens. Oh, actually 1 carbon and 5 hydrogens. So since this one only has 6 hydrogens and this has 5 but has a carbon, this is going to be the highest priority. And I can draw right here what I mean. So when we go out, we're looking, so first we observe this carbon and this carbon, but this is the same bond. So then we go out to this one, these two, and then we take this hydrogen. So you always want to skip, you never want to get like focus on 1 hydrogen, 1 carbon of the same molecule. It's every other. So then this one we were focusing on these 2 carbons with 1 hydrogen, which is equal to this side right here. We have to go out 1 more. So this one has a carbon. This side doesn't have any more carbons, so that's why you're only counting the hydrogens, which means it's 6 hydrogens. This is 1 carbon, and you count the outside hydrogens from the bond before, which gives 5 hydrogens. So this side is greater than this one. Okay, so first, second, third, and this is a clockwise position, but since the hydrogen is face out, we're going to switch it around and it's going to be S, and that's the third position, so 3S. And then we're going to observe this one. The hydrogen is in the back, so we won't have to change it. We can keep the confirmation because we know it's going to be true. So of course we've got the 2 branches again, 2 branches, and like we saw before, the one with the extra carbon attached is usually the one that has it, but let's check it out. So 1 carbon, 1 carbon, 1 carbon, all the same, go 1 more out. 1 carbon, 2 hydrogens. 1 carbon, 2 hydrogens. 1 carbon, 2 hydrogens. Oh, sorry, 3 hydrogens. 2 carbons, 1 hydrogen. So this one would be the greatest confirmation because you've got 2 carbons right here that you're observing, 1 hydrogen. This one you only have 1 carbon with 2 hydrogens. This will always be 3 hydrogens. So greatest, second, third, this is going in a clockwise position. So it is R, and we leave it because the hydrogen's in the back. And that is the 4th position, so I'm going to go ahead and put 4R. Hopefully that is right. Okay, so we're going to draw a heptane. 1, 2, 3, 4, 5, 6, 7. Methyl on the 3, methyl on the 4. Add some hydrogens, hit arrange, fit, and roll. Okay. So the drawing ones are a little more complicated because you have to manipulate the molecule if it's not ready already. So let's see. We've got a hydrogen poking out, so this one's going to be the opposite of what it is. I just identified the chiral centers, but we can go through that. 2 hydrogens here, 2 hydrogens here, 2 hydrogens here. These are 2 chiral centers. So I see 2 carbons attached to a carbon, so I know this is going to be the highest priority. 2 carbons, 1 hydrogen, 1 carbon, 2 hydrogens. So 1, 2, 3. This is counterclockwise, so this would actually be R. So that one is correct. And let's see for the 4R. So I see the 2 right here, only a long branch here. So this is going to be the highest priority. 2 carbons right here, 1 hydrogen here, 1 carbon here, 2 hydrogens here. 1, 2, 3. This is counterclockwise, so we're going to have to turn this around to make it an R conformation. So you want to put it on its side. And this is the part that I have the most trouble with, so let's see if it works out. I'm going to roll it again and try to get that hydrogen on that side. So it's right here. I'm trying to just switch them around. So the hydrogen is in the back and the methyl is in the front. Okay, I got my 4 conformation here. We're going to go ahead and check it and see if it's right. I got my highest priority here, second, third. It's going clockwise, so that's the R position. I'm going to make sure this is correct as well, that I didn't change anything. So highest priority, second, third, going around R clockwise. So let's see if it's right. Okay. Draw a heptane again. Methyl at 3 position, methyl at the 5 position. Add your hydrogens, arrange, fit, roll. Okay, so I see we have R conformation S. So this might be right, but it might also be reversed. So I look for my chiral center, 2 hydrogens here, 2 hydrogens here, 2 hydrogens coupled here. This is my 3rd chiral center and my 5th, or it could be the other way depending on which way you're reading. So let's start with this one first. I'll say this is my 3. So I see the branches right here. So it's far out, so I'm gonna actually count it to double check. So I just immediately skip this one because they all have carbons and they're all the same right here. 1 carbon, 2 hydrogens. 1 carbon, 2 hydrogens. We go 1 more out. 3 hydrogens, no carbons because we don't have another bond here. We go 1 more out. 2 carbons, 1 hydrogen. So 2 carbons and 1 hydrogen beats the 3 hydrogens. So this is my first conformation, second, third. It's going around in the clockwise position, but as we know, so that would be S, but as we know, the hydrogen's poking out. So this would actually be an R. So the 3R is correct. And let's look at the 5 position. So I see the same structure here, but opposite. I can still count it. You got 1 carbon here, 2 hydrogens here. 1 carbon here, 2 hydrogens. We got to go 1 more out. 3 hydrogens here, no carbon because there's no other molecule here. 2 carbons, 1 hydrogen. So 2 carbons and 1 hydrogen beats 3 hydrogens. So this is the highest conformation. This is the second, and this is the third. It's going around in the R position. So this, since the hydrogen's in the back, that's the right conformation, but we need S. So we're gonna have to turn this one around as well. We have to switch the position of the hydrogen and the methyl. This is the part that I don't like. It's really ugly. Okay. Let's hit arrange and fit, and let's see if it moved the right way. Okay, so I have that hydrogen in the front now. So let's double check. This was a higher conformation. This was the second conformation, and this was a third. It's going in the R position. But because the hydrogen's poking out, this is actually S. And of course, I'm going to double check the side too, just to make sure. We got our highest conformation on this side. We got second, third. This is going S, but the hydrogen is poking out, so it's actually R. Let's see. Okay, I'll do one more. Okay, so we're going to write the name first. 1, 2, 3, 4, 5, 6. This is hexane. 1, 2, 3, 4. So we've got a methyl on the 3 position and a methyl on the 4. Either way you read it, it's going to be on the 3 position and the 4. So 3, 4, dimethyl hexane. And now we're going to look at the chiral centers. I see 2 hydrogens here, 2 hydrogens here. These are the outside, but they have 3 hydrogens each. Here's my third position chiral center and my 4th position chiral center. So I'm going to look at this one first. Hydrogen's poking out, so we got to remember that. I see these 2 carbons attached to a carbon, so I'm going to assume this is right, or the highest priority. 2 carbons, 1 hydrogen. 1 carbon, 2 hydrogens. 2 carbons and 1 hydrogen beats 1 carbon, 2 hydrogens. Highest priority, second, third. This is going in the counterclockwise position, so we're actually going to change that, and that's going to be R, since the hydrogen's poking out. So I'm going to go ahead and put 3R. And now I'm going to look at the 4th position chiral center. The hydrogen's in the back, so that makes it easy for me. I don't have to change anything. So 2 carbons attached to a carbon is going to be this one. 2 carbons, 1 hydrogen. 1 carbon, 2 hydrogens. This is greater conformation, or greatest priority. Second, third, this is going clockwise. So we're going to leave it like that since the hydrogen's in the back. And that's going to be the R position. For R, parentheses, dash. Okay.